All right, negative exponent properties. So we talked about the zero exponents. Now we're going to talk about negative exponents, starting with our lovely for any integers. We love these definitions. Any integers a and m where a does not equal 0. All right, if we have a to the negative m, that is the same as 1 over a to the mth power. If we have, or if we have 1 over a to the negative mth power, that's the same as a to the positive mth power. And so if you think about it, like if I had 4 to the negative 2, I'm not looking at 4 times the negative 2 or negative 2 squared, right? So it's not like 16, negative 16. Remember, that's not how that works. But what I'm thinking of is if I go back 4, from 1, right? Because 4 to the 0 is 1, and then 4, 1 is 4. But if I go this direction, 4 to the negative 1, right, would be 1/4, right? So we're going back. 4 to the negative 2 would be a 1/16. Okay, so it's taking it from where we have it, and we're from 0 and taking it back, in this case 2 times. Now you don't have to work it this way, but I'm telling you like why that works to where we're just moving where my base is. So in this case 4 to the negative 2 would be 1 over 4 squared, and 4 squared is 16. Okay, so let's do some examples. Now, what they're wanting you to do when it comes to these quotient rule ones is keep the base still, but they're wanting you to think of it as 8 minus 11, which would give us 2 to the negative 3. And then because it's a negative 3, we know we need to put and right now it's in the numerator. 2 as a whole number is in the numerator, so then we are going to move it to the denominator and make it 2 cubed. Now, I say that's what they're that's what they're expecting you to do. What I suggest is you look where the number's bigger, right? 11 is bigger than 8. So instead of moving the 11 to the top, I know since 11's bigger, we're going to keep the 2 in the bottom. Something has to be on top, so I'm going to put a 1, and then I'm going to think of it as 11 minus 8. So again, we still come out with 1 over 2 cubed, but when I take just a little bit of time to think about where that's going to be placed, I no longer end up with the negative when I subtract and then have to move it down. So that's what I'm suggesting. So when I look at B, we have 100 over 200, and again, not equals, times our B, 75 is bigger in the bottom. So B is going to be in the bottom, and we're going to do 75 minus 50, and we'll put the 1 back on top. All right, so 100 over 200 is 1/2. So we have 1/2. Now, the 1 stays, so 1 times 1 is 1. 75 minus 50 is 25, so we get B to the 25th, with the B being in the bottom because that's where it was bigger. And so we have 1/2, or 1 over 2 times B to the 25th power. And that's how it works. All right, so again, if I think of these separated, a to the negative 3 over a to the 5th, b to the 7th over b squared, and c to the 5th over c to the 7th, I'm going to, 5 is bigger than negative 3. So when it comes to our answer, a is going to go in the bottom, and we're going to do 5 minus a negative 3. And I do highly suggest writing out, even if it's just scratch paper, 5 minus a negative 3, because when we start getting negatives in there, we have to be careful of our integer rules. Now when we look at the b's, 7's bigger. So I'm going to have my b in the top, and I'm going to do 7 minus 2. And then c's, the 7 again is bigger, but it's on bottom, so c is going to be in the denominator, and we're going to do 7 minus 5. So from here, 7 minus 2 would give us b to the 5th power over 5 minus a negative 3 becomes plus a positive 3. So we end up with a to the 8th power. C to the 7 minus 5 is 2, so c squared. But if we would have just done all the subtracting going up, we would have had to move a and c back down. So this is why I highly suggest just looking at it, figuring out which exponent is the bigger one when going to subtract, and keeping it in that place. Now this one, I would do power of a product first and distribute. The reason I distribute is for a problem like y, like we could put all of this over 1, but for like this y to the negative 5, it's going to end up becoming positive. So I like to see what may become positive before I start moving things. So in this case, we're going to end up with 2 to the negative 2, x to the negative 6, because 3 times negative 2 is negative 6, and y to the 10th power. So the y is going to stay, but these two have negative exponents. So we're going to end up with y to the 10th power over 2 squared times x to the 6th. And then I'm going to evaluate the 2 squared, so y to the 10th over 4, x to the 6th. And that is our final answer. All right, and so that's how negative exponents work. We have one last thing. It's just classifying whether it's greater than 1, equal to 1, or less than 1. So negative would make this where we have 1 over 3 squared. So this one is going to be less than 1. B, we have 2 cubed. It's a whole number, right? So this is going to be greater than 1. 3 squared, again, greater than 1 because it's a whole number. It's not a fraction. 2 to the negative 3rd power, we would write that as a fraction, 1 over 2 cubed. So that means this is less than 1. 3 to the 0, anything to the 0 equals 1. And 2 to the 0, again, anything to the 0 equals 1. But if you're getting any problems like that, that's what you're thinking about. If you're moving it into a fraction that is less than 1, then the answer is less than 1. If it's a whole number that you're taking to an exponent, it is greater than 1. And then that's it for exponents. Until next time where we start scientific notation. Bye, 8th grade.